I have one more treat for you. I have an iron core, soft iron. This is not a magnet. This is a magnet. This is not a magnet. This is a magnet. This is not a magnet. Now if I take, oh, there's my loop. If I take a copper loop, right now there are no field lines through that copper loop. By hitting this button, I turn this into a magnet and suddenly put a whole lot of field lines through this loop. That loop doesn't like change. Now these field lines spread out at the end of the bar magnet. If this doesn't like change and it didn't have any field lines through it to begin with, where can it go to fight the change? Up there. Now here's another way of thinking of it. If hitting this button turns this into a north pole, then suddenly I'm going from 0 field lines up to a lot of field lines up. The ring is going to fight that by putting induced field lines down. That's going to put a north pole against a north pole, and it's going to jump. Now, if I have an aluminum ring that's lighter, yeah. Now, what about this copper ring that has a slice cut through it? Nothing. Now, the battery is set up as I change the number of field lines through this loop. That's fixed. But if I could somehow make this a better conductor, less resistive, I would get a bigger current, a bigger induced current, and it would become a stronger bar magnet, and it would jump higher. Now, clearly, I need more space. Now listen carefully. When it gets to 320 below, you'll hear a crescendo, and then it will stop. Here it comes. Okay. I got it. Now, if I warm this up, it's not going to jump as high. Okay, Joseph, stand up and catch it. But don't hold it. Catch and release. Okay, are we ready? Catch and release. Send it back. Thank you. Okay, folks, we'll pick this up on Friday.